In this pencast, we're going to be learning about regular and non-regular polyhedrons. So this problem says, is the solid a polyhedron? If so, is it convex? And then, is it regular? Alright, so we have three parts. And to do this, we're going to need to know some definitions. So let's look at our definitions first. So, polyhedron, the definition of that is a solid bounded by polygons, which means all the faces have to be polygons. So for it to be convex, it says, if any 2 points on its surface can be connected, sorry, that's a little messy, by a segment that lies entirely inside or on the polyhedron. Alright, and for it to be regular, it says all the faces are congruent regular polygons. Alright, so let's start with A. So the first question is it a polyhedron? So are all the faces polygons? Well, it looks like all the faces are comprised of straight edges, which means that's a polygon, and they're all enclosed. So we're going to say yes, this is a polyhedron. Alright, so now we need to know if it's convex. So can any 2 points on its surface be connected by a segment that lies entirely inside or on the polyhedron? So let's just make some examples. So if we want to connect this point to this point, connect them like that, that's going to be on the face. If we want to connect this point to this point, that line stays entirely inside the polyhedron. So far we're good. So you can try that with any number of different points on the polyhedron. You'll find that all of them lie inside or on the polyhedron. So yes, this is convex. Alright, and the third question is it regular? So that says that all faces are congruent regular polygons. So we can see these tick marks right here indicate congruence of these sides. So we can see that all the faces are squares. So that makes this a regular polyhedron. Alright, so for part B, let's see here. So the first question is it a polyhedron? Solid bounded by polygons. So this face right here, this face is a circle. That's not a polygon, which means that this is not a polyhedron. Alright, so the next question is it convex? So if we draw lines in here from any point to any other point, can we always go through the polyhedron? Or through the shape. It's not a polyhedron. So the answer to that is yes. So it is convex. Alright, and then is it regular? Are all the faces congruent regular polygons? Well, we already know the top and the bottom are not polygons, so they obviously can't be congruent regular polygons. So, no, it's non-regular. Alright, so C. Alright, so this one says, is it a polyhedron? So, is it a solid bounded by polygons? I don't see anything that's not a polygon here. All the faces are composed of straight edges. Even this one, even though it's an odd shape, it's still got all straight edges, which means that it is still a polygon. So, yes, this is a polyhedron. Alright, so is it convex? Alright, so on this one, let's say, if we draw between this point and this point, we're on that face, that's good. This point and this point, we're on this face, that's good. But what if we use this point and this point? Do you see how this line is not in or on this shape? The same with these 2 points right here. Or any point on this plane, really. So that means that this is non-convex. Alright, and then it asks if it's regular. Are all the faces congruent regular polygons? Obviously not. This face on the outside right here is not the same as any of the other faces. So this is non-regular.